Introduction to Algebra, Part 7, The Concept of Zero. At the end of this lesson, you will know the history of zero, or at least a little bit about it, and understand the special properties of multiplying and dividing with respect to zero. Today, we actually take the concept of zero for granted. We sign online, we go to our bank, and our bank account is zero. We have no money. But the concept of zero is actually a relatively new concept in our history. Now, in history, in the Western European history, we've always had the concept of nothing, having nothingness. But there's a difference between the concept of nothing and the concept of zero, which is that number between -1 and 0. And so, for centuries, while we had a firm understanding of mathematics, we really didn't have a good concept of what existed between the numbers of -1 and 1. Now, in Western Europe, the idea of zero, the value zero, appeared really about 1200 AD. But interestingly, the church condemned the use of zero for some very odd and peculiar religious reasons surrounding around the understanding of God, and condemned the use of the number zero in mathematics until the year 1600. Now, we can compare this with the history of other civilizations and realize that we in Western Europe did not have exclusive domain over mathematics. In Babylon, they had the concept of zero starting as early as 450 BC. In the Americas, the Mayans had the concept of zero as around 350 AD, and in India, we saw the appearance of the number zero as early as 450 AD. So, in mathematic concepts, Western Europe was way behind in this one particular area, almost 1,000 years. Now, when we start talking about mathematics and algebra, we really need to talk about four different concepts. Now, the first one is adding and subtracting with zero, then multiplying by zero, dividing into zero, and then ultimately the dividing by zero. Now, adding and subtracting zero is pretty straightforward. If we add zero to a value, it doesn't change the value. And if we subtract from zero, it doesn't change the value either. And when we think about that concept of, I have 5 apples and I add 0 apples, how many apples do I have? I have 5 apples. So 4 plus 0 equals 0. And also, if I have 5 apples and take away no apples, I still have 4 apples. So we have things like 4 plus 0 equals 4, 4x plus 0 is still 4x, and 5y minus 0 is still 5y. Now, multiplying by zero gets a little trickier. So when we multiply any value, regardless of its contents, by zero, the value is zero. So 4x times zero is zero. And 0 times 5x minus 4 is 0. And 0 times 4 over x plus 27 is 0. So that's really convenient for us when we're doing calculations, because if we see a complex multiplier and we know that something is 0, we can simply say, well, the value is 0. Now, we can use this concept of multiplying by a 0 by a number is 0 in calculating equations. So let's take the first example of 4x times 5 minus x equals 0. What values are valid for x? Well, we know if 4x is 0, then the value is 0, so we know one value for x can be 0. But we can also say, look, if 5 minus x is 0, then we also know that it's going to be 0. So we have two possible values for x, 0 and 5. Both of those make that equation true. Now let's take another example of x squared times 5x minus 25 equals 0. Now that's a pretty complicated equation. Now, first of all, we can take that x squared and we say, look, if we take x squared times 5x minus 25, if that x squared is 0, then we get 0. So one value for x is 0. But we also know if 5x minus 25 is 0, regardless of what x squared is, that stuff in the parentheses is 0. So we know that x could be 5. So we have two possible values. X can be 0 or x can be 5. Now, when it comes to dividing into 0, we want to be aware that any value divided into 0 equals 0. So 0 over 25 equals 0. And 0 over 25y equals 0 as well. Now, we can use this concept of dividing into 0 to simplify equations. So let's take the equation 5x plus 25 equals 0 over 3x. Now, We know 0 over 3x, no matter what value x is, with an exception we'll talk about in a little bit, is 0. So we can say 5x plus 25 equals 0. 5x minus 25, so that means 5x equals negative 25 and x equals negative 5. And we can actually look at this and say 5 times negative 5 is negative 25 plus 25 is 0 and equals, and 0 and divided by 3 times negative 5. 3 times negative 5 is negative 15 and 0 is 0. So we know that works. Now let's take another example where we say 4y minus 16 equals 0 over y cubed. I'm looking at this saying, wow, this is going to be really complicated if I multiply it through. But instead, we know that 4y minus 16 equals 0, right? So y equals 4. Now, we talked about dividing into 0 as 0, but what happens if we're dividing by 0? And what we want to realize is that any number divided by 0 has no meaning, and we call this as being an undefined value. So if we take 25 divided by 0, there's no number times 0 that's going to be 25, so this is undefined. So if we have 4x divided by 0, it's also undefined because no number times 0 is 4x. So that means we occasionally will want to check our calculations and make sure we're not dividing by 0 somewhere. So take 5 over x minus 4, calculate for x over 4. Well, 4 minus 4 is 0. We're dividing by 0 in the denominator, and so this is an invalid equation. It's undefined. So let's go through some questions, and you can pause at the end of this this slide, so you can answer the question. So first of all, what is the value of the following? 0 times 2 to the 12th power plus 15 times 4. Also, what is 5 minus 5 times 3 plus 4? Now, what is the value of the following if x equals 5? X minus 5 times x plus 4. What is the value of the equation above if x equals negative 4? What values are valid for the variable x in the following equation? X plus 27 times x minus 14 equals 0. And then what are values valid for the variable x in the following equation? X minus 16 times x squared equals 0. So let's go through some more questions. Solve for the value of x in the following. 4x equals 0 over 25x. 5x minus 5 equals 0 over 3x. And 14 equals 5x over 0. So let's go through the answers. The first one is, what is 0 times 2 to the 12th plus 15 times 4? Well, we got a 0 right at the front that we're multiplying by, so we can completely ignore what's in the parentheses and say it's 0. Now let's take a look at the second one. 5 minus 5 times 3 plus 4. Well, we know that 5 minus 5 is 0. So whatever 3 plus 4 is, even though it's 7, doesn't matter. We know that it's 0 times some value, so it's 0. Now let's take a look at the following. We have what is the value of the following if x equals 5? Well, we have x minus 5 times x plus 4. Well, we know it's 5 minus 5, which is 0. X plus 4 is 9, but it really doesn't matter because we're multiplying by 0, so it's 0. Interestingly also, what is the value of the equation if x is negative 4? Well, now we've got negative 4 minus 5, which is negative 9, times negative 4 plus 4, which is 0, so it's also 0. So we know that for this there are two values where it's 0. Kind of interesting. Now, let's look at the following one. X plus 27 times x minus 14 equals 0. What values of x make that 0? Well, we know that we can take the first part, and we say, well, if x is negative 27, well, then that's 0. So that will give us 0. But we also know that x, if it's 14, will give us 0 on the right-hand side. And that would be 0 times x plus 27. So there are two possible values for x, negative 27 or 14. Last one, what are the values are valid for the variable x in the following equation? X minus 16 times x squared equals 0. Well, we can start by saying we know if x is 16, 16 minus 16 is 0. And so even whatever value 16 squared is doesn't matter because it's 0. But we also know if x is 0, 0 times 0, x squared is 0. So there's another value, 0. So we can have x equal to 16 or x equals to 0. Okay, now let's go through the next set of questions. The first one was 4x equals 0 over 25, solve for x. Well, 0 over 25 is 0, so we have 4x equals 0, and that makes x 0. Now our next one said 5x minus 5 equals 0 over 3x. Well, we know 0 over 3x is 0, and so we have 5x minus 5 equals 0. Well, we say, let's move the 5 over. 5x equals 5, so x equals 1. Next one, 14 equals 5x over 0. The answer is it's undefined. There is no value we can put on 5 where 5x over 0 equals 14. Thank you for watching this video.